Hello students. Today I am going to explain a very important topic of physics chapter magnetic effect of electric current. The topic name is electric motor DC motor. DC means direct current motor. It's a motor which works on the DC current and it is a device which is used for converting electrical energy into mechanical energy. So it converts electrical energy into mechanical energy. Oftenly you have seen a water pump at your home, that is example of a motor. And how it was, it received electrical energy, and after that, after receiving electrical energy, it converts to this mechanical energy, and due to this mechanical energy it converts to potential energy, which is used to draw water from ground to up. So here you can see, this is the structure of DC motor. First of all, try to understand DC motor structure. See, these these two are the magnets. One is the north, one is the south, and at the center it is a rectangular one. This is called armature. It's a coil. It's a coil but acts as an armature here. And here you can see this ring is there. This ring is called a split ring or commutator. These two are the bushes, carbon bushes. It is made up of the carbon, especially that is graphite. Graphite bushes are this. And after that, this one hole is connected with a source of energy, that is the battery. Its basis of working is Fleming's left hand rule. You can see what is left hand rule. Already it is given you. When a coil carrying current, when a coil carrying current is placed in a magnetic field, it experiences a torque. What means torque here? Torque means here deflection, and deflection force, and deflection means when a coil carrying current, this is the coil carrying current, current is passed to this to the battery. Then what happened, two magnets are here, so it is a magnetic field around it. So this coil experiences a torque, and torque means what? Deflection. Deflection means kinetic energy, means it experiences both force and deflection. So when it experiences force and deflection, then results in, as a result of this torque, the coil begins to rotate. So in simple language, try to understand. You are passing electric current from the battery. When current is passed to this coil to the battery, then what happens? This coil, because it is surrounded by magnetic field, two magnets. Therefore, what happens? It experiences a type of force. Experiences type of force. That force helps it in the deflection, and due to deflection, what happens? It start rotating, and one formula is already given you, that is the F is equal to ILP or BIL, both is same. So what is here? I is the current, L is the length, and B is the magnetic field. So one thing try to understand. Here what happened when current is passed, so current is same current is passed to both the sides of the coil. Length of the coil is same, magnetic field is same, there is no change. Then what happens? This way, this electric current or this battery current experiences a force on this coil, and due to this force of the coil, it start rotating. It start rotating this way, and first it rotate for 180, and again it rotate another 180 degree. So when it rotate 180, at the same time this splitting also start rotating. And the function of splitting or commutator is what? Its function is only this, to change the direction of current within the coil after every half rotation. So after every half rotation means once this coil experiences a force, a torque, or deflection, then it rotates 180 degree, and this is called half rotation. And after this half rotation, this split ring or commutator help to current change the current direction of the current. And this way what happened, when the direction of the current is changed, then again this coil moves for 180 degree half rotation, means one time in the same one direction, another time in the different direction. So this way this rotation continue, and it start working similar. And same time you can see here in this one axis is given. Through this axis you can connect one turbine or one fan, and due to this turbine and fan it get energy, and this mechanical energy converts to kinetic energy, and which help in the rotation of the motor, and it works properly. So these four five parts are there in this DC motor. One is the armature, very clearly it is shown here. This one is the ABCD is called armature. And second one is the field magnet. These two field magnets are there, north and south magnet, which creates a magnetic field around the armature. Then the split ring or commutators are there. This is the split ring or commutator. Its function is what? Its function is to change the direction of current within the coil after the half rotation. And next one is the two carbon pieces are there. This is made up of the carbon means graphite, and after that one battery is there. So one more question, basic question is there, very important question is there on the topic of this DC motor. How can you change? How can you increase the rotation of the motor? So speed of rotation of the motor can be increased by increasing. 4 points are there, and it's very easy to remember. You can remember it just like a Meena. So what is Meena here? Meena may be the name of any girl is there. So don't mind it. So Meena, here M for magnetic field. It means if you increase the magnetic field, then the rotation of the motor will also increase. Second one is the current. Means if you increase the current through the coils, then also the rotation of the motor will increase. Third one is the number of turns in the coil of the armature. So this also you remember that there are the number of turns wrapping of the copper wire on the armature. So if more the number of this copper wires wrapping is there, wounding is there around this armature, then more will be the strength of the motor, means modulate the rotation of the motor. And next one is the area of the coil. So if area of the coil is more, means size of the coil is more, then the magnetic field produced by the coil also will be more, and then the speed of the rotation of the motor will also be more. So these 4 points are there: Meena, M for magnetic field, I for current, N for number of turns in the coil of the armature, A for area of the coil.